It's a tricky question, isn't it? And it's so abstract, it's very difficult, even once you've worked out the right answer, to determine what is it that what did I just answer? Like, I didn't even know, okay? So let's try and walk through it, and then hopefully over the next few minutes you can, with me together, determine what we've done. Let's read out the question, and then I'm going to put down the relevant information on the board. A population N of T. Now, by the way, very quickly, I think, if you're like me, as you start to work out this question, you start to forget what any of these things mean. They just become letters, right? And you just start thinking index laws and how to shift things around and solve simultaneously and so on. I think it's really important that you always have, at least kicking around somewhere in the back of your mind, what is it that these letters stand for? I mean, this is a population and this is a time, right? And it's not a complicated idea. But many of you, when you've gotten the right answer at the end, and I say, now what is that? And the answer, we haven't been able to give me an answer, okay? So for those of you, there's 4 or 5 of you who have already gotten all the way down to the end of part B, okay? Your real question to answer, I wonder if you can answer it before I get to the end, is, what have we just calculated for part A and for part B, okay? Population N, it varies with time according to the law, and they give you this equation, which matches, which matches exponential growth and decay. Okay, so that's why it comes under this topic, right? And then they give you some markers. They say C and K are, are positive constants, so they are some kind of real number, and T is greater than or equal to 0. By the way, even though these both seem like restrictions, I'm keeping them separate. Why? Think. Why are they separate? Think back to some of the questions we've been doing recently. C, K, and T are not the same category of pronomen, right? What are they? C and K are constants, right? Which is why I locate them in a set of numbers. And I say, look, these guys, they're a number in there. I don't know what they are, but it's an actual number and it fits those characteristics. Whereas when I go for T, well, that's a variable, right? So do not confuse those. Okay, great. Let's move on. Part A. Show that if, now I'm going to give you the fancy notation for this, even though you don't have to write it like this, at least you want to be able to interpret it. Okay. A and B are 2 positive numbers. This is part A. Okay. A and B are 2 positive numbers, so they belong to that set as well, such that, in set notation, that's a colon, such that A plus B equals 1. Okay, so now I not only have a range for where these guys are, but I also have a connection between them. Okay. What do I want to show? This awkward looking result. This AT plus BU equals gross. Okay. To the A and to the B. For any T U greater than 0. Okay, stop for a minute. Particularly for you, those of you who've worked out the answer already. T and U, what are they? T and U, what are they? They're numbers, but they're more than numbers, aren't they? They're being fit into here. They are times, right? A T is obvious. We're used to thinking of T as time. They've just put in U because they want another time, right? So this is, literally, I'm going to say, that's some time in some point in time, and this is another one. Okay, do you need to know that that's what they are in order to manipulate this? No, but if you want to understand what's going on, then you do. So if this is what I want to show, which do you think it's easier to do? Go from the left-hand side to the right, or the right-hand side to the left? What do you reckon? Which way have you guys gone? It looks like it's easy to start from the right, okay? Because N of T is defined for me. N of U, not defined, but I can very easily get it. Okay, so that's where I'm going to begin. Right-hand side. I'm just going to write it as is, right? So here's my line. Okay, so now I just got to go to my definition for what N is, right? And substitute that in with T and U. Okay, so I've got C e to the KT here, and I've got C e to the KU there. Okay, Now, remember what you're headed towards, okay? What is this? This is going to be CE to the K, all of that, right? That's everything that's going to be up there in the power, okay? So that's where I'm headed towards. When I simplify this, what's going to happen? Well, just your index laws here. CE to the K T A, right? And CE to the K U B. Now, what can you do at this point? Where can you go? Don't forget, you have some relationships in here, don't you? For instance, you know that A plus B equals 1, right? And so because you've got these being multiplied by each other, you're going to expect that A and that B to become A plus B, right? How am I going to put it together? How do I rearrange it? I should take a C out, shouldn't I? Okay, sorry, that C should have an A as well, and that C should have a B as well. What do I have with the C, right? Well, I've got CA and CB, right? So that's really just A plus B, isn't it? Is that okay? There's the one that I'm expecting. Then I've got all the E terms, right? I'm going to add all of their indices together, like so. Is that okay? So that there is C to the power of 1. It's just C, okay? In order to make it clear, right, because what I'm trying to prove is a foregone conclusion, right? So it's all in the working, right? And in order to make it clear that this is exactly what I want, I should probably take that K out, shouldn't I? Right? What's going to be left in here, it's going to be this phrase up here. AT plus BU. There you go. I'm done, more or less. I just need to rewrite it in terms of the left-hand side. That's the population at that time. It's an awkward looking time, isn't it? But that's what it is. That's what they've asked. I've gone from right-hand side to left-hand side. Good, I'm done. Okay, part A, no problems. Just be careful with your index though. Now, part B. Okay, they give you this information. They tell you this, and they tell you this, and they want you to find this. Okay? I'm still posing the question to you. What does, for instance, this line which you've just proven, what does it prove? And how does it relate to this? Keep it kicking around your head. I'll give you a little more time to think. How do I bring this information to bear on what I've just proven and get an answer out? What am I going to solve for? What do I have to find? I've got two equations here, right? So I'm expecting probably there are going to be two unknowns. What are they? A and B, right? I don't know what these constants are. I know that they add up to 1, but I don't know any other information about them, okay? But if I choose my values for these other numbers in here, well, then I'll get an equation out, right? So for instance, let's go with the right-hand side, because I can see an N3 and an N18, some places where I can slot those in, okay? The right-hand side would look something like this. Let's see, let's call this T and this U, right? So I'll have N3 here to the power of A, okay, times N18 to the power of B, okay? If that's the right-hand side, what's the left-hand side? T is 3, U is 18, right? So I'm getting, let's see, what is this? 3A and 18B. Is that all right? Those are just these numbers over here. Can you see how it's parallel to what we just worked out? So far, so good? Okay, now I know what these are, right? That's a 10, and that's 100. Right? Is that okay? Can I do anything with this? Where am I going to go? What kinds of things? I need to put these together in a simple form, right? It's a bit obscure what I can do with this here. I need to find A and B. How am I going to do it? What kind of equation am I going to get?
Simultaneous.
Well, okay, I've got some simultaneous equations up here. I've kind of used them, but this on its own is not enough, right? What am I going to do with it? What conclusion can I draw from this line?
different.
Why is this equal to 13? Why are you jumping to that? Why are you saying this? On what grounds? It's because it's a simple answer, right? But it's for those of you who've gotten stuck around here, right? It's because that's what I want. That's all. It's just what I'm after, right? So A and B, I'm just going to choose convenient values that will get me to this value, okay? So now I have an equation. I guess I'll call this 3, okay? I need one more to be able to solve this, but they gave it to us right at the beginning, right? What are we going to use? A plus B being equal to 1. Okay, so there are 2 equations just in A and just in B. Okay, now you can put them together. I think do you get A as a third? Or is it 2/3? Which one is it? A is a third, yeah. A equals a third and B must equal to 2/3. Okay, is that all right? Yeah. So now what you've got, you come back up to here, you can say n of 13, right? Because that's what happens when you put these values of A and B into there, you get 13, is going to be 10 to the power of a third times 100 to the power of 2/3, right? But of course 100 is just 10 squared. So this is really 10 to the power of 4/3, and then you just use your index laws. Okay, you get to there, right? Now I'll ask you the question again. Does this seem like a reasonable value? The problem at this point, the reason why when most of you sort of gave me a sideways glance when I asked you this is because you don't know if it's a reasonable value, because you don't know what any of this means. So have you had enough time to try and settle the meaning, the purpose of all this in your mind? Okay?
Yeah.
Tell me what this line is. Tell me what this line is. What is it? What are these 2 things?
Time.
They're times, so therefore that, right, each of those is a population at a certain time. Is that okay? These are both populations at certain times. What's this guy? Well, if this is a time and this is a time, another time, this is still another time, right? So this is another population at a different time. What's this tell you? It tells you, if you know the population at 2 times, I can tell you the population at another, right? Let me draw it for you, okay? It's an exponential. It fits this kind of shape, right? So you're getting, whoop, wrong one. You're getting this. What's the initial condition? Look at it, go on. What's the initial condition? C, right? Okay, now what they're providing to you in part B is the population at time 3 and the population at time 18. Let's plot that. Time is over here, okay? So time 3 might be here, then 6, 9, 12, 15, 18, thereabouts, okay? So they've said, look, here, it's population 10. My graph's not quite right. Let's call it a logarithmic scale, then it's sort of okay, right? There you go, 2 populations at 2 different times. And then they ask you, now, what is the population in the middle somewhere, right? Where did I say? That was 15, wasn't it? So somewhere like this. 13. Okay? So what you proved in part A was a relationship between 2 points in the curve, any 2 points you like, and a third point. And that should make sense. Once you know 2 spots on the curve, you should be able to define the whole thing, right? Because you know beforehand what kind of gradient it's going to have and how it curves upward. Okay. So then you worked out an intermediate population given 2 other points on either side of it. Okay. And demographers and population kind of control people, population studying kind of, what are they called? Anyway, they use these kinds of models all the time because, of course, you know, when they say, oh, the population of the planet is going to be 12 billion in such and such a point of time. How do they know that? They don't have a time machine, right? Well, they've got records. They have records, right? And they can use that to predict things. You can see just as easily I could have picked a value of time over here and I would get a value. Okay? 2 unit, huh? Yeah, it is. Have a look at all the things we did. We did some index laws. What's that? U9. We did some simultaneous equations. Also U9, maybe 10. Okay. Why is it so hard? Why was it so difficult? It's very abstract, isn't it? Your final answer out here ends up being about 46, which sort of does, at least it's in the ballpark. And if you have something more than 100 or less than 10, you know that you're wrong, right? It's okay. Work out your errors afterwards, that's fine. Okay.